Good afternoon again, everybody. Can you guys see my screen?
Yeah.
Okay, so today we'll talk about, we're going to solve some linear inequalities and also learn how to graph them. So first, let's define these linear inequalities. So an inequality is the opposite of equality or equation. So an inequality is when two sides are not equal. Let's say A and B, they are not equal. So this is an inequality. Usually we see greater than, less than, greater than or equal to, less than or equal to. So these are the symbols we use to express inequality. So far we learned equations. Previously we talked about first degree equations, something like this, with an equal sign, and there was an unknown here with a degree 1. So this is what we call linear or first degree equations, and we learned how to solve these in detail. Solving inequalities is quite similar to solving linear equations. Same steps, basically. With these inequalities, we need to add, we need to graph. So their standard form also looks like this, but instead of an equal sign, we have one of these comparison symbols. So the standard form would look something like this. For example, C. So one of these symbols here, so standard form. Okay, as an example of that, maybe x greater than 5, x less than or equal to -3, x minus 2 greater than or equal to 4, for example. Um, 12 here, for example, and so on. Basically, it's just like, almost looks like an equation, except for the comparison symbol part. So all the different types of equations we saw, the different forms, we can also have equalities in that form. Solving them again is very similar to solving linear equations. There's one lot of difference. We'll talk about it later. But all the other steps are pretty much the same. So with linear equations, we usually need to solve first and graph them. Solving just means getting the x by itself, just like we do with linear equations, and graphing them is when we put them on a number line like this. We have positive numbers here and negative numbers. So we put the inequality here on the number line, either going to the right, to the left. We'll see in the next step. So let's start with graphing, actually, because that's the new part. Solving we already know, similar to solving equations. Let's start with graphing, which is pretty simple itself, too. Okay, so graphing inequalities. Let's take this inequality x greater than 2. And also x greater than or equal to 2. They're a little bit different. So before we graph an inequality, make sure that x is by itself. It means it is solved. If it's not solved like this or this, then we need to do certain steps, just like we do with the equations to solve it. So this one is already by itself, the x by itself. Let's grab it. So we need a straight number line, 0 in the middle. So we know we have positive numbers on this side, negatives on this side. We just want to locate this number. It's positive, so it's going to be on this side. No need to put all the other numbers on the number line, just the number that's in the inequality here. So this is the symbol for greater than. Okay, this symbol here, x greater than 2. So what this means is we want to graph all the numbers that are greater than 2. Basically, we start from 2, which is here, and then we want all the numbers that are greater than 2. So we start from 2 and we go to the right. Because to the right, we find numbers that are greater than 2, like 3, 4, 5, 6, and 7. But to the left, we only have numbers that are less than 2. So we don't want those. We only want the numbers that are greater than 2. And let's now understand the difference between these two symbols. They both mean greater than. This one is greater than, this one is greater than or equal to. That's what this symbol means, greater than or equal to. Let's see what happens here. So let's say we want the numbers x that are greater than 2. What's the first number you will start from if you want to get numbers x that are greater than 2? What is the first number that we can use? Here.
1.
Greater, bigger. So what's the first?
3, 4.
That's right. So the first number would be 3, 4, 5. So any number that's greater than 2, starting from 3, is basically a solution. So that's what we have this arrow for. And it keeps going, it does not stop, because the numbers here go up and here go down to positive infinity, negative infinity. So numbers that are greater than 2 start from 3. What about the numbers that are greater than or equal to 2? Where do you start from? For this, so if you wanted the numbers that are greater than or equal to 2, what is the first number?
2.
That's right. We start from this to itself because it has or equal to. Here, we jump the 2 because strictly greater than 2. We jump to 3, but for this one, we say start from 2 itself, it's included because of this. So we say 2, 3, 4, 5, and so on. So that's the difference between these two. It just means whether to include this or not. If you have or equal to, that's part of the solution. Take 2, 3, and so on. If not, this is not part of the solution. The next number is, and when we graph to explain or to show on the graph that this 2 is not included, we use a little circle like this. That means the 2 is not included because of this symbol. It doesn't have or equal to. However, if you want to graph this one, again, 2 is here. So we want the numbers that are greater than or equal to 2. So we start from 2. And we go to the right. So greater to always go to the right. If it's less than, it would go to the left. But the 2 itself is included because of this. So here we use empty circle to mean that the 2 is not included. But for this one, we're going to use a shaded circle, meaning start from the 2 itself. So basically this and this mean the same thing. So any number that's 2 itself and more or higher is solution, as we said here, 2, 3. But for this one, the numbers start from 3, even though it looks like we start from 2 here, but this means that 2 actually is not included, rather 3, 4, and 5. And it works the same way if we have less than, so greater than, we go to the right. The only difference, if this was the other way, we would go to the left instead. So that's the difference when you see that little line here next to inequality. It works the same way with still another one, maybe -1 and x less than or equal to -1. So again, we need a number line. 0 in the middle. So x is by itself. We can graph it. Where do I find -1 on this number line? So we need a starting point here on this graph. Where do we find -1?
Behind the 0.
That's right. It will be to the left.
To the left.
The left with negative numbers. So we have -1. And if you want x or numbers that are less than -1, -1 is here. If you want the numbers that are less than -1, do I go right or left? Less than. So -1 is here. We want to get the numbers that are less than -1. Are we going again left or right? For greater than, as you can see, we go to the right. But for less than, we need to go to the left because the numbers on the right are higher than the numbers on the left. So we start from here and we go to the left. That's for less than. Is the -1 itself included or not? This -1. Do we include it in the solution or not? In other words, do we use a circle here or do we use a shaded circle for this inequality? So the numbers that are less than -1, then the first number would be -2. Okay, not including this -1 because again, we don't have that equal to, so this is not included. We're gonna use the circle. So not -1, we skip -1, we go to -2, -3, and so on. For this one here, we want the numbers that are less than -1, less than or equal to -1. What's the first number we start from?
-1.
That's right. We have or equal to, so we start from that number itself. So this will be -1, -2. I mean, I'll go in this way. Yeah, that's right, -3.
And it would be a shaded circle.
Exactly. So we're including the -1. So this one not included. That's why we have this. But for this one, so 0 would be here. -1 somewhere over here. Again, x less than. So less than means go to the left. And since we have or equal to, we include in the number itself. So this is a filled shaded circle. That means we start from -1 itself, -1, -2, and so on. So there is a difference between that word line here. It just means whether to include the number itself or not. So when we don't have it, the number is not included. We skip it. So -3, -2, -3, and so on. If we have that or equal to, we do include that. So, for example, when you there are some places that say that require a certain age in order for you to get in. For example, it says 18, you have to be 18 or older, or 21 or older, for example. So 21 or older, it just means greater than or equal to 21. Whatever this might be, for example, X is the age. So if it's 21 or older to get in, if you're 21, can you get in based on this? Or
No.
if you're 21, so X or the age, for example.
Oh wait, yes, you can, because it's X is equal to 21 or greater.
That's right. So 21 or older, that's what it says usually. Yes, you can get it. But if you're 20, obviously you can't get in if you're 20. But what if it says that age must be greater than 21? Would you be able to get in if you're 21 based on this inequality?
No, you can't.
Yeah, that's right, because this means strictly greater than 21. So this one means it starts from 22, 23, and so on. But for this one, it could be 21 or higher. So including that 21. So this is included. So we write it down 21, 22, 23. So that's what we mean. It's just basically an extra line here, which means an extra word usually, or older, or this or that. So it's a whole concept of inequalities and graphing them. And that's the new part. So solving them, it's just like solving equations, so it shouldn't be that bad. Whatever we learned with equations applies to this. Almost the exact same step, except for one case when we change things a little bit. And we're gonna talk about that when we get to it in a few examples. Now let's look at any questions, everybody, about graphing before we move on to solving? Everybody?
No.
Okay, so questions. Let's go over to solving linear. And also graphing them. Solving and graphing, why not? Because at the end, once we solve it, we need to graph it. Unlike equations, we didn't have to graph them, because usually when you solve equations, you have exactly one solution. For example, x is 3. Nothing to graph here. Sometimes there is no solution. Sometimes we have many solutions. So if you have many solutions, usually it's infinitely many, which means any number can be a solution. But with inequalities, we have plenty of solutions. They start from a point and they go either right or left. So we can't list all the numbers, instead we just use a graph. For an inequality, to say that any number that's higher than 2 is fine, or any number that's less than -1 is fine. But with equations, we have one specific solutions, or none, or infinitely many. So there was no need to graph the solution set in the first 3 equations. Okay, so let's look at these. For example, let's take that one. It's -2. X -2 greater than or equal to 4. So one step here, just like with the equations, what do you do to get the x by itself?
Add 2 to both sides.
Say it louder a little bit. Get close to the mic.
Add 2 to both sides.
That's right. So think of this as an equal sign for a moment. Okay. Whatever you do with equations, you can do with inequalities. I'm just going to add to both sides to cancel these. So x is greater than or equal to 6. Once you get that x by itself, no negative for a number, that's when you know you're done. You just need to repeat the same stuff we did over here to graph it. So with the number line, 0, 6 would be on the right side. How does the graph look like, and where does it go? Is it shaded or not, right or left? 6 greater or equal to 6.
It's going to the right from 6.
Okay, to the right because it's greater than. Is it
It's going to
shaded?
be shaded.
That's right, it's shaded because we have what equal to. That's all there is to it. Okay. Again, you just have to solve first, and very simple to graph. Left or right, shaded or not shaded, very simple. Let's do that one. So let's call this examples. So that was example 1. Let's do another one over here. It's a -6. Okay, or just less than 12. All right, so let's solve this first. We need to get the x by itself less than something. Once we do that, we can graph it. So what do we need to do here first?
Order of operations.
Okay, so what's the first operation? To do?
Separate 3 and x and 3 and -1 by themselves.
Okay, so that means we distribute. Okay, we use a distributive property where we multiply, so we have 3x minus 3, bring down the -6 less than 12. And what happens next?
We add like terms.
That's right, we combine these two terms here. The 3x, -3 minus 6 is?
-9.
-9, that's right, less than 12. After that, now it's going to look like this. We're going to repeat the same thing. What cancels next?
+9 on each side.
That's right, +9, +9.
3x equals 21.
Less than, that's right, 21.
Yeah, less than 21.
And finally, divide by,
Divide by 3.
that's right, divide by 3, divide by 3. So x will be less than,
X will be less than 7.
exactly. And that's all. So that's our solution. So the question is halfway solved. So this is half of the credit, whatever the question is worth. This is half of the credit. The other half would be allocated for the graph. 0, what was in the middle, 7. And how does the graph look like this time? Right or left, shaded or not?
Not shaded, and it's going to be to the left.
That's right. So not shaded. Going to the left. So less than always goes to the left. Less than goes to the left, and because we don't have that extra line here, it means not included, or a circle here, not including 7. Any number less than 7 is fine, not 7 itself. And basically the inequality could be any of those equations we saw before, fractions or no fractions or whatever. It works the same way. You're just gonna get your x by itself. And once you do that, you solve. There's one, okay, let's do another example this time, maybe with something like this, 5x plus 3 greater than 4x minus 1. Just like with equations, you're gonna do whatever we did with this as well. If you remember with equations, what do we do here?
You got to get all the variables on one side, so you can -3 from both sides and -4 from both sides.
Exactly. So we're gonna move the x's to one side and the numbers to the other. What happens if you move something to the other side? What happens to the term when it moves to the other side of the equation or the comparison? Especially to its sign, what happens to it? We switch the sign. So we know you move something to the other side, the sign's going to switch to the opposite. This stays here. Now we're going to move +3 to the other side, turns into -3 and -1. Now we can combine the terms. So we have 5x minus 4x is x or 1x greater than -4. Make sure again the x is by itself without a number or a negative sign or a fraction. And again, very simple to graph, this time -4. Okay, which way is the graph? Show you the graph is going. So greater than will be going to
To the right.
the right. And of course it's
Not shaded.
not shaded. Okay, so that's one thing. When you see this, just again recall what happened to equations or what we do with equations and apply the same thing. You may have a whole bunch of parentheses here and numbers, maybe on the other side as well. Just work on each side, simplify the other side until you get the x by itself. So that's what we're interested in, this solution of the 4 by itself, or the x by itself greater than -4. And we graph. There's one thing here that happens, something special that happens sometimes when you have, let's say you have -2x, maybe less than, let's say, 6. This is a one-step inequality. We can solve it in one step. What do we do exactly here to get x by itself?
Divide by -2.
That's right. Divide by -2 on both sides. Does anything change or something special happens here if we divide by -2?
Besides, you're going to get a -3? No.
You're going to get a -3.
X equals -3 because the negatives cancel out.
There will be x here, that's right. It will be -3. But anything else special?
X is less than -3?
So it is, initially, it is less than -3. But it will actually flip to the other side. Because we divided here by negative because of this negative. Just like, for example, you have, I don't know if you have.
Also, since it's a positive now, it's okay. Because
because of this negative. Just like, for example, if you have 10K in your account, right? 10K. If you multiply this by a negative, what happens to it? So if you here you go 10K, you're rich. But if you times this by negative, it flips, it will become an overdraft of -10K in your account. So you immediately turn from 10,000 richer to rich to negative 10K, poor or less, just with that negative. So it's like multiplying, it's like dividing by a negative. If you divide this amount by a negative, it turns into something that's on the opposite side. Or you can also look at it this way. There's another explanation. So when you say, for example, 8 is in fact less than 3, right? That's true. Is it? No, I mean, not. It is less than 10. So that makes sense. What happens if you divide both by a negative number, for example, by -10 or -1? Will it still be true if we divide? This will be -8. This will be -10. Will it still be true? Is it -8 still less than -10?
Yeah, it is.
Is it still this? The -8 is here, -10 is here.
No, -8 is greater than -10, so it would switch.
That's right. So this will turn to the other side. The -8 is on the right. The numbers on the right are always higher than the numbers on the left. So that's the reason why only if you divide by negative, this flips to the other side. If you divide by a positive, nothing changes. If you have, for example, 10 greater than 6, you can divide by a positive number, for example, 2 and 2 will still be 5 greater than 3. Okay, nothing changes because we divided by a positive number. That's why nothing happened here when we divided by 3. This stayed the same, but if this was a negative and we divided by negative, we would switch this to the other side. So be careful with that. That's probably the only difference when it comes to solving equations and inequalities. So that changed to this. And now we can graph this easily. So we graph 0 here, got -3. And so we're going, so x is greater than, so we're going right. And of course, not including the -3, so we're going to use a circle here. Okay, so remember that step. If you're solving for some reason, you end up with a negative here. So you got to divide by a negative, and this will flip to the other side. Otherwise, everything will stay the same. This again, pretty much how you solve these. You may come across different types of inequalities in the homework, but again, it just should be just like equations. So let's do one more example here with maybe some fractions. Let's say x over 3 plus, let's see, 1/6 will be greater than or equal to 2/9. We want to solve this and graph it. Again, think of this as an equation for a moment, just to basically think about the same steps you do with equations. So what would you do first here to solve this equation or inequality rather? What's the first thing that happens here?
Find a common denominator.
Very good. So we need to cancel all these denominators, just like we do with equations. So the LCD for 3, 6, and 9, what is it?
3.
3. So the LCD is a number that all can go into, not a number that can go into them. They all can go into it evenly, or a common multiple.
Isn't it 3?
If you put 3 here, so the 3 goes into 3, but 6 does not go into 3, 9 does not go into 3. So it should be a higher number that all these can go into. It's a basically common multiple of all of these.
18.
Say that again?
18.
18, that's right. So the first or the least common multiple for all these is 18. And once you find the LCD, what do you do with it? Okay, we have our inequality, we have the LCD. And how do we use that LCD to cancel the fractions? Just like with equations, basically just write the LCD next to each one. Okay, just write the next to each fraction and reduce to cancel out all the fractions. So we have 6x plus plus 1 times 3 plus then cancel here too, so 2 times we have 2. Okay, so once you get rid of all your fractions, again, I'm just going to be repeating what we saw earlier here. So this will be 6x plus 3 less than 4, and I subtract 3, 6x cancels less than or equal to 1. And finally, divide by 6. So x is less than or equal to 1/6. We don't have, well, we can't simplify this fraction, so I'll reduce, so that's the solution. It is a fraction. Where would you find 1/6? Which side of the 0? Which side of the 0 would you find 6? Obviously, it's a positive number, so it's got to be somewhere over here. You don't care exactly where, as long as it's positive. But if you have 1, 2, 3, have all the numbers on the number line, you can turn this into a fraction. You can turn into a fraction and find the specific location. Let's say here We want to find, let's say we have 1, 2, 3, and we want to find where 1/6 would be exactly. So if you divide 1 by 6, it is 1.16. If you divide 1 by 6, 1.16, actually 0.16, so it's going to be somewhere over here. Okay, so that's where the 1.1/6 would be 0.16 or 17. Okay, but if it's 1, for example, 1.5, 1.5, it would be here. So divide this. If you want a specific place, you can divide this if you have a number line with numbers on it. Otherwise, you just need to put it on the right side of 0 if you don't have any numbers. So this will be, so less than means we're going to the left. And it's included, so we're going to use a shaded circle. And that's pretty much how you solve inequalities and graphing. Graphing is simple. Solving is also simple and similar to solving linear equations. And just be careful of this special case here. It's only time when something unusual happens. Make sure you flip the inequality to the other side. Okay, so everything else should be similar to solving first degree equations. Okay, any questions, everybody? If you have any questions, please let me know before we start give you some practice to do on your own. All right, so here are a few problems here. So work on these on your own. Again, do the same thing. So make sure you can do this easily without a problem. If you can't do it now, if you don't learn it now, I don't know when you will learn it. You may never learn it. So take advantage and do this on your own right now. So solve on graph. X higher than -2, x less than or equal to 4, x plus 1 greater than or equal to 7, and all right, and also, or maybe just make this -3. Okay, there's another one. A minus minus, and all right, that's pretty much it. So take a few minutes to work on this, and I'll check with you afterwards. Just a reminder again, the midterm is next week. The review sheet is posted, so make sure you work on that sheet and do the whole thing. The exam will be based on it, so try to understand all the problems there. If you have any questions, we can have a review on Tuesday, next Tuesday. The exam will be next Thursday. All your homeworks are due as well by the midterm day. But the homework is important for your grade. It's about 20%, so make sure you complete all your homeworks. Okay, so get working on this stuff, and I'll check back with you in a few minutes. Okay, everybody, let's go over this together. So this one is already solved. Just need to graph it.
So it's going to be a open circle, not shaded, to the right of -2.
Exactly. So to the right of -2, open circle. Very good. So that's the first one, -2 here. You have 0 here. Maybe 1 here, 2 or 3. Okay, what about the next one?
It's going to be a shaded circle to the left of 4.
That's right. So there's 4. So it's going to be shaded because of or equal to and going to the left. Plus down is always going to the left. And over here, first need to solve it.
So we would have to solve. So we would take away 1 from both sides.
That's right.
And x would be greater or equal to 6.
To 6. That's right. And then we need.
So it would be a shaded circle, and it would go to the right.
That's right. There's 6 to be shaded. So greater than will be going to the right. All right, that's good. Now you have a couple of longer ones. So we're going to solve here. So
We would start with order operations. 2 will be 2x minus 8 plus 8 is less than -3.
Okay, and over here what happens?
We would combine like terms, so it would zero out because it's -8 plus 8.
That's right, these are opposites, they cancel out.
2x is less than -3.
That's right.
And we would want x by itself, so we would divide by 2.
Divide by 2. Do we flip this?
It would be x would be greater than. It wouldn't flip if we're dividing.
Only if we have a negative here. Only if we do here.
So then x would be less than 1, -1. Wouldn't we simplify it?
We want to graph it, so.
Yeah, it would be -1, 1/3.
Well,
I mean 1/2, sorry.
1.5, 1.5. So when we graph, we need to have decimal, so we know exactly where to put the. If you have 0 here, so where would -1.5 be exactly? Between what numbers?
It would be between 2 and 1.
Between negative?
-2 and -1.
That's right, -1, -2. So this will be right in the middle.
And it would be not shaded.
It would be not shaded, that's right. And going to?
It would be going to the right. To the left.
Less than, that's right. To the left. Okay, so when we graph fractions, we can turn them into decimals. And we can, that way, know exactly where to put them. All right, there's another one here, the final one. So this one is a little interesting. So what happens here first?
We would want x by itself.
All right, we're gonna move this over. Also gonna move the negative back here. So we wanna combine like terms first. So we have -7x. What happens to -5x? We move this over here. What happens?
Add 5x into 7x?
That's right, so this will turn, the sign will switch. If we move it over to the other side, it will be positive 5x greater than The -2, if it moves over, turns
will
into,
be plus, it would turn into a positive 2 plus 4.
that's right, +4.
It will be negative 2x greater than 6.
That's right.
We
And
want x by ourselves, so we would divide by -2. And then the sign was switched because it's negative. So it will be x is less than -3.
exactly. So the only time we switch this is when you have a negative here. And this, so the negatives cancel out, +1, so x less than -3. Kind of like what we did earlier, but we had, yes, we kind of did something like this. It turned out to be exactly like that. And finally, you just need to graph this. So I need a line, 0. Okay, so we'll start from -3. And it will go to which direction? We'll go less than, so we'll be going to the left. And that's pretty much it for graphing and solving inequalities. Very similar to equations in steps. And again, this only switches when we have a negative here. Not here, it didn't switch because this was a positive. It's not about this negative. If there was a negative here, that's when it switches. And that's about it for tonight. Any questions, everybody?
No, Professor.
Okay, everybody else, you guys all right?
No, thank you.